This is a tutorial about physical and chemical properties as well as changes. So the first slide talks about properties. The next slides are going to be talking about changes. Okay, so all properties of matter are either chemical or physical. You could define them that way. If you're talking about a chemical property, you're basically talking about a property that allows something, a substance, to undergo a chemical change. So we're talking about bonds. So for example, oxygen sustains a flame. That's a chemical property. Sodium burns in water. That also is a chemical property. On the other hand, physical properties are a little bit easier to understand. They're the characteristics which you can observe or measure without changing the identity of a substance. So basically, it's easier to look at these examples and understand what a physical property is. So if I say something like the physical property of water is that it's a liquid, it is clear, it has a boiling point of 100 degrees Celsius, right? It is a liquid. Those are all physical properties. Now, how about physical and chemical changes? Well, it's basically the change that's occurring. It's like the action verb. Something is really undergoing that transformation. Okay, so that's the difference. A property is just kind of like a list of things, like statements you make. A change is actually like now we're actually going through the action of it. So a chemical change is a change in composition of material. So what happens is your substance actually breaks bonds and new substances are created. And the way that happens is the bonds rearrange themselves and form new bonds, and you get a brand new substance. That's really important, the fact that you get a new substance. There's a definite change of appearance. This occurs when reactions take place. Okay? So some good questions to ask yourself is, did a reaction take place? How do I know? And the last question works sometimes, so you have to be careful about the last question. Is the process reversible? So let's take a look at this picture in the lower right-hand corner. So if you notice, there's some sort of a chemical is being added to a powder. Let's pretend this is vinegar and baking soda. And when I add those two together, bubbles form. If bubbling occurs, then you have gas being released. This is a great sign of a chemical change, meaning that vinegar, that baking soda, when they came together, they formed a new substance. They no longer are vinegar and baking soda. So in order to do that, bonds were broken, new ones were made, and new substances got created. That's important. Once I've created my new substance, sometimes you can figure this out by asking yourself, can I reverse it and bring back the vinegar and baking soda? And the answer to that is no, you cannot. Okay, so that's a really good way to see if you have a chemical change. Another good thing to say in your head also is, does my substance look different? Okay, and sometimes you have to be careful about this because you want to make sure that it actually looks different because you have a new substance, because something changed, not because you just colored over it. Coloring over something is not a chemical change. Next, physical change. So a physical change is completely different than a chemical. Okay, so it's a change that's occurring, and basically you're altering an appearance of something, but you're not changing the real stuff it's made out of. You're not affecting the bonds. Okay? So I left off by saying coloring is not a chemical change, but you know what? Coloring over something is a physical change. So like if I add food coloring to water, I'm just changing the appearance of water. It's still water. So that's a physical change. Yes, it looks like red water, but it's still water. The matter that it's composed of did not change. Look at the picture in the bottom corner. I have ice, and if you notice, the ice is melting. Ice is made up of H2O molecules. When it melts and turns into liquid, is it still H2O molecules? Sure, it's just water molecules that are now a liquid. This is just a physical change. No bonds were broken, and I didn't form anything new. It's still water. And what if I was to take that water and evaporate it? Well, it would just turn to water vapor, which is a gas. Did I create a new substance? No, it's not like when you evaporate water, you get syrup. No new substance forms, it's just water in a different state of matter. So a change of state is a physical change. And you do change the appearance, but you have to make sure you're looking at the fact that you're changing it kind of more on, I guess a good way of saying it is like on the surface, right? It's not like the real thing has been altered. Okay, so ask yourself, did I need to react this material to observe this property? Because physical changes do not involve reactions. And is it reversible? Now, this is a good question to ask yourself, and it works the majority of the time. Physical changes are reversible for the most part. So, when ice melts into a liquid, that's a physical change. Can I bring the liquid back into ice? Yep, I could freeze it. See? Physical change. So here are some examples. Why don't you take a couple seconds, or you can pause the video to do these examples now. In the first picture, a piece of paper is on fire, physical or chemical. You should have guessed chemical change. Anything that involves fire is usually a chemical change. If you notice, when fire comes into contact with a paper, you get something new, which are ashes and gas. So, can you bring your paper back? No, it's gone. So all the bonds have been broken and new things have been formed. That's a chemical change. The second picture is showing colors, leaves changing colors in the fall. Chemical or physical change? This one's a little tricky. It's actually a chemical change. If you remember back from biology, leaves, in order for them to change, go through photosynthesis, and they have chlorophyll in them, and there's a whole chemical process, and that chemical involves chlorophyll. So there's actually a whole mechanism involved, and hopefully you remember that from biology. The last one is glass being shattered. Chemical or physical change? Well, let's take a look at this. This is glass, and it shatters. Yes, there are many, many pieces of glass, but is it still glass? Yep, it's just glass in 1,000 pieces. So I didn't change the substance, so it's physical. How about a few more that are not listed here? Let's talk about maybe cooking. What if I cook an egg, or cook a steak, or bake some chicken, or bake a pie? How about all of those? Are they chemical or physical? Think about what you should be asking yourself. Go back and look at the slide to see what you should be asking yourself. The answer to those are chemical. Those are all chemical changes. When you start off with an egg or a steak, for example, and you cook it, you can't bring it back to a raw state. You have altered the bonds and you've created a now cooked version of the steak. That is considered a new version, so that is a chemical change. So you might want to try to see if you can classify things. Things that involve fire and cooking seem to be chemical. Okay? Now, let me throw this at you and see if you can get this. My steak is already cooked, and I just want to heat it up. Maybe I'm heating up some leftovers. So I take my already cooked steak and put it in the microwave, and it heats up. Physical or chemical? I hope you said physical. It was already cooked, and now I'm just making it warm. So just going from cold to hot is just a physical change. Can it become cold again? Sure, let it sit out. How about this one? What if I take a piece of paper and cut it in half? Chemical or physical? Hopefully you said physical, right? I just changed the appearance of the paper. Instead of being one piece, it's now two pieces. It's not like when I cut it, water pours out of it. That would be something new, but that doesn't happen. Okay? What if I react explosive sodium with toxic gas chlorine? And when I react them, I get table salt, sodium chloride. Is that a chemical or a physical change? Hopefully you said chemical, right? What was once an explosive substance and a toxic gas now created an edible substance. There you go. That's a brand new substance. Can I get back the explosive substance? No. How about the gas? No. Catch my point? See you in class.